The last question in this note packet is example 18. We are going to look at two people, Bob and Bonita, and they are both saving for retirement, but in different ways. And we're going to try to figure out, based on their savings plans, who is going to end up with more money for retirement. Okay, so let's take a look. In example 18, consider the retirement savings plans of Bob and Bonita outlined below. Okay, so part A, we're going to talk about Bob. Okay, so let's move this up. All right, Bob makes his first $1,000 deposit into an IRA, which stands for Individual Retirement Account, earning 6.4% compounded annually on his 24th birthday, and his last $1,000 deposit on his 35th birthday, which is 12 equal deposits in all. With no additional deposits, the money in the IRA continues to earn 6.4% interest compounded annually until Bob retires on his 65th birthday. How much is in the IRA when Bob retires? Okay, so make sure you read this a few times until you understand what's going on. Okay, and when you're ready, you can come back to the video and we will compute how much Bob has in his retirement account. Okay. All right. So Bob's got a couple of things going on here. Okay. So he's got his IRA. The interest rate is 6.4%. Okay. Everything's compounded annually. The interest is compounded annually. He makes deposits for a while, not the entire time. That's important here. When he did make deposits, they were annual deposits. So make sure you realize that. So basically, he starts off on his 24th birthday making these deposits, and his last deposits on his 35th birthday, and they actually count them for you. It's 12 deposits in all. I mean, you could take your fingers and count, and you could do 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. Okay. If you count on your fingers, yes, it's 12 deposits in all. Okay. And then after he makes that 12th deposit, then he just lets the money sit there. He forgets about it essentially. Okay, there's no additional deposits. The money just continues to earn interest. Okay, and again, it's compound interest. Okay, until he retires on his 65th birthday. Okay, so there's a couple of things going on here. Okay, all right, so we're going to break this up. Okay, so we're going to talk about, first of all, what happens between ages 24 to 35. Okay, because he's making deposits. So making regular deposits. Okay. So during that period of time, since he's making regular deposits, that is going to make this future value of an annuity. Okay. Because he's putting how much? $1,000 in every year. Okay. All right. So that's what we're going to work with here. Okay. All right, so let's see. I guess I'll scroll over here and kind of write down the variables. Okay. We are of course, again, you were breaking this up into two parts. Okay. This is just up until age 35. Okay. We're always looking for his account balance. How much is in his retirement account? So we're looking for A. Okay. In this case, P would be the amount of each deposit. Okay. That's going to be $1,000. The interest rate is 6.4%. The M value is going to be 1 because the interest is compounded annually, the deposits are done annually. Okay, so M is 1. And then time, be careful here. You're only considering these ages where he's making the regular deposits. Okay, that's 12 deposits in all. So we're assuming this is a 12-year period. Okay, all right, so that is how this works for this first part. Okay, we're going to put all of this in, and that will give you the account balance at the end of the 35, around the 35th birthday mark. Okay, so let's plug everything in. Okay, and then you're just going to go to your calculator and put this in exactly like you see it. All right, so just put all this in real quick, and then we'll go to our calculator. All right, here we go. All right, so going straight to the calculator. Okay, again, We're going to start inside the brackets, enter the numerator, get that answer, divide by the denominator. That will give you the quantity in brackets, come back, multiply by 1,000. Okay, so that's the plan. All right, so let's get the calculator. Okay, so we're going to type in the numerator. Let's start there. So open your parentheses. We're going to have 1 plus 0.064 divided by 1, close parentheses, raise it to the 1 times 12 power. Okay, get out of the exponent, subtract 1. There's your numerator. Okay, we need to divide this by r over m. So hit the division key. Okay, so open parentheses, got to have parentheses here. R over m, close parentheses. This gives me the quantity in brackets. Okay, we need to multiply this by 1,000. So hit times 1,000. Okay, and you're going to get this decimal. Okay, this is going to be dollars and cents. Okay, so let's go jot this down and talk about whether or not we need to round at this point. Okay, because again, this is only bringing us through age 35. Okay, so we still have to go to age 65. So we're not done with Bob yet. Okay, all right, so I'm going to come up here. Okay, this is the number that came out of the calculator. All right, imagine that at the end, imagine that Bob went to his mail, okay, and he got a bank statement, okay? This is not what it's going to say, okay? It's going to give him an account balance with dollars and cents, okay? So at this point, you do need to round to the nearest cent, okay? So we have 21 cents. There's a 7 after, so we need to round up. So after age 35, okay, at that point in time, his account balance is $17,269.22, okay? So going into year 36, okay, this is what he's starting off with, okay? So what's going to happen here, okay, so now this is going to be like 36 to 65, okay? You can again count on your fingers. This is going to be a 30-year period. Okay, so I'm going to write right here. My pen went crazy. Okay, it's moving all over the place. Okay, hold on. Okay, so this is a 30-year period. Okay, so what's going to happen now is that this amount of money just sits there. He doesn't put anything in, he doesn't take anything out. And so this money just earns interest, compound interest, because the interest is compounded annually. Okay, so this becomes, for the second part, this becomes a compound interest problem. Okay. All right. So at this point, okay, I'll go over here and write down your variables. You're still looking for the account balance. Okay. But P is the one lump sum of money that is invested. That's this balance that he had after age 35. Okay. So that's going to be this amount. Okay. Same interest rate, still compounding the interest annually. Okay. Time has changed. Okay. Again, this is ages 36 to 65. Okay. That is a 30-year period if you count on your fingers. Okay. So we're going to put all of this in, okay, to our formula for compound interest. Okay. Trying to squeeze it in here so it fits. All right. And then we'll go type it into the calculator. Okay. And then that will give us how much Bob ends up with for retirement. Okay, so let's go on to our calculator and put this in to see how much he ends up with. Okay, all right, so let's see. I'll go ahead and clear this out. So open parentheses, we're going to have 1 plus 0.064 divided by 1 raised to the 1 times 30. Okay, so whoopsie. All right, so that's what you get, but then you have to go back, remember, and multiply by the 17,000 number. Okay, so we've got to multiply this, make sure you carry all the digits, multiply by $17,269.22. So that's Bob's whopping total at age 65. Okay, so let's go write this down. This is dollars and cents. You are going to have to round to the nearest cent. Okay, all right, so this is what came out of the calculator. All right, so we got a round. Okay, he's got 76 cents. You have a 6 after, so you need to bump it up. Okay. So Bob has for retirement, he has $111,050.77 based on the way in which he saved. Okay. So now let's look at Bonita and see what she did differently, and then we'll see who has more money for retirement. Okay. All right. So let's read about Bonita in part B. Okay. She procrastinates and she doesn't make her first $1,000 deposit into her IRA until she's 36. But then she continues to deposit $1,000 each year until she's 65. So it's 30 deposits in all. If Bonita's IRA also earns 6.4% compounded annually, how much is in her IRA when she makes her last deposit on her 65th birthday? Okay. So Bonita's the procrastinator. Okay. Remember, Bob did things in increments. So from ages 24 to 35, he was putting in those $1,000 deposits. He only made 12 $1,000 deposits. And then he stopped depositing money and just let the money sit there and grow through compound interest. Okay. So you had to break it up into two parts from ages 24 to 35 and then from 36 to 65. Okay. Bonita, she's only doing stuff from ages 36 to 65, which is again a 30-year period. Okay. The difference here is she is making $1,000 deposits the entire time. Okay. So there are regular deposits the whole time of $1,000. Okay. So for her entire saving history, we're going to use the future value of an annuity formula. Okay. All right. So again, we're just trying to figure out her account balance at age 65. Okay, so we're looking for the account balance. P is the amount of each deposit, so it's $1,000 each time. Same interest rate as Bob. Okay, so we can compare the two. Okay. Again, ILM is 1. There are $1,000 deposits every year. The interest is compounded annually. Those two things coincide. And time for Bonita, she's saving from ages 36 to 65. That is a 30-year period if you count on your fingers. So 36 all the way up to 65. Okay, so let's put all this in. Okay, and then we'll put it in the calculator, and then we will be able to decide who has more money. All right, so here we go. All right, so let's go take a look at our calculator. Okay, so again, with this formula, we're going to start in the brackets, put in the numerator, divide by the denominator, then multiply by the 1,000 out front. So let's go do it. Okay, I'll clear out the last problem. Okay, start in the brackets in the numerator, open parentheses, 1 plus 0.064 divided by 1 raised to the 1 times 30, close parentheses, get out of the exponent, subtract the 1. There's your numerator. Okay, you want to divide by R over M. So hit your division key, open your parentheses. Well, we're going to have R over M, close parentheses. This is the quantity in brackets. Now multiply by 1,000. Okay, and this is how much Bonita has for retirement. Okay, you can already see she is going to have a lot less. Okay, all right, so let's jot this down. Okay, so her account balance comes out as this in the calculator. Okay, again, round to the nearest cent. Okay, so we have 51 cents, a 0 that comes after, so we're going to keep it the same. Bonita has $84,852.51 for retirement. Okay, part C says who has more money for retirement? Definitely Bob. Okay, from this example, okay, remember who made more contributions? Okay, Bonita definitely put a lot more in. Okay, she made $1,000 deposits every year for 30 years. Bob made $1,000 deposits for only 12 years. Okay, so this example really shows you, you always hear you should start saving early for retirement. Bob started at age 24 versus 36. He only had to put in 12 deposits, okay? Whereas she started later and had to put in deposits every single year, but she still ended up with a lot less money, okay? So the moral of the story is that compound interest is very, very powerful, okay? And start saving early for retirement. The end.